Good day. Welcome to Yebo Tutor live stream help on this beautiful Monday. I hope you're all good. So today we'll be doing chemistry. Uh, I've been receiving many many queries. People wanted this topic, which is called the organic chemistry, which is in paper 2 of your physical science 2022. So what I want us to do is that I want us to look at this chapter. It consists of 50 marks in your trial and also in your final exam. So I want to make sure that I touch everything. I do the touch basis for everything and every concept you can get it. So without wasting much time, if you are a returning subscriber, thank you so much. And also, if it's your first time to watch us live, please do subscribe, do comment, do like, and also you can follow us on our social media platforms. We are available in all the social media platforms: Facebook, Instagram, as well as TikTok as well. You can follow us there. And also in the description of this video, you will find out that we have attached the WhatsApp group link where you can actually join the WhatsApp group as well, so that you can actually receive the additional materials which we give to the students so that you can prepare for your exams. So without wasting much time, so we'll be going through the question paper, which is 2021 trial exam preparation. So as you can see, we're gonna do those questions right now. But before we go there, I would really love us to go and like check what I call an overview. I want us to have a small overview because I feel like it's so important. It's so crucial that we have an overview of the concept of what we are talking about when we are talking about the organic chemistry. So today, as I said, we'll be doing organic this organic chemistry. So an overview. So on my overview for organic chemistry, I want us to look at what is this organic chemistry. So we must also understand that organic chemistry, it is the study of structures, properties, and reactions of chemical compounds of carbon and hydrogen atoms. So organic chemistry is revolving around the studying of the properties, the structures, and the reactions of carbon and hydrogen atoms. So the key which is important is that we are dealing with the carbon and hydrogen atoms. Okay, that's something which is so crucial and so important to understand, that we are dealing with this. All right, so now moving forward, I also want to make sure that you understand that we have what we call organic molecules. Organic molecules. So what are organic molecules? Of course, we have defined what is the organic chemistry, and we say that it is the study of the structures, the properties, as well as the reactions of hydrogen and carbon atoms. But now we want to look at what is an organic molecule. How is it going to assist us in understanding in depth organic chemistry? So organic molecules, these are molecules. These are molecules that contain carbon atoms. So organic molecules, these are molecules that contain carbon atoms. So also what is important is to understand that many organic molecules, they are found in living organisms, and these organic molecules, they are so crucial because they are also used and given names, or are named according to their properties, according to looking at their functional groups which they fall under, as well as also the homologous series on which they fall under. So from there, there are key definitions which we must look at on organic chemistry. For the first one, we have what we call hydrocarbons. So what are hydrocarbons? Why am I defining this? Because when you're writing your exam, definitely they'll ask you these definitions. Okay, so what are hydrocarbons? So you must know that these are organic molecules that are made up of hydrogen and carbon atoms. Okay, so let me write this as well. These are organic molecules that are made up of hydrogen and carbon atoms. Underline only. Okay, this is so important to understand that only carbon atoms as well as hydrogen atoms. Then what is a homologous series? This definition, they are so crucial. So we must know that we have what we call the homologous homologous series. So what is a homologous series? So a homologous series, it is a family. It is a family of organic molecules. It's a family of organic molecules in which all molecules have the same functional group. They're the same functional group, but with different length of carbon chains. Okay, so we are just having some small few definitions which are so important and so crucial. And also we must now understand that, so we said they have the same functional group. So now the second question, what is a functional group? Okay, what is a functional group? So what is a functional group? Now that's the second question. So what is a functional group? Okay, so it is a bond, atom, or group of atoms which identifies which identifies which identifies to which homologous series that molecule belongs and is responsible and it is responsible for that it is responsible for that it is responsible for that chemical properties. Great. Now moving forward, I have this table which is so important. Now I already have defined the key or the basic important terms, which is to understand what is organic chemistry, and to say that it is the study of the structures, the properties, and the reactions that these molecules will go through. Now we also defined what are organic molecules. We also defined what is now the homologous hydrocarbons first, so that you can understand that we are dealing with carbon and hydrogen atoms. So when we are talking about structures now, it's so important, it's so crucial that you understand that these structures, they are so important in the sense that you must be able to draw these structures, okay? You must be able to know the functional group, okay? Because now we say that what is a functional group? We say that a functional group, it is a bond or it is a group of atoms which identifies to which homologous series that molecule belongs to. So these molecules, they can be in the same functional group, but they can have a different parent chain. So what is a parent chain? The parent chain is determined by the CH, which is the condensed formula, which is CH, or the bonding of carbon and hydrogen atoms. So if they have 500 carbon atoms in a long or in the parent chain, which means that's a pentane. I'm just making an example. If you're looking at an alkane, then if they have 3 now, still now it's now what? If it's 3, what is it? It's 5. We said if it's 5, it's pentane. And maybe if it's 4, it's called what? If it's 3, it's called what? So those things, if it's 2, we know that it's now dialkyl. So those things are so crucial and so important to understand that yes, they are of the same functional group, but now the naming of those organic molecules, they will be named in a different way. Why? Because they are having different parent chain. So now I want to draw this table which is going to assist you in the process of understanding this concept, right? So now what is important now is to understand the homologous series. Then we have the structure of the functional group. Then we also have the name ending. Then you must also understand, this is the important things. Let me just also put the condensed structural. So we have 8 of these things, 8 of the homologous series which we'll be looking at. The first one is an alkane, the second one is an alkene, the third one is an alkyne, the fourth one is what? The fourth one, we say that we have the 8 of these things in the homologous series. So the first one of the alkanes, alkynes, then we have alkyl halides, we also have alcohols, we have ketones, we have aldehydes, we have carboxylic acids, and the last one, which is most important, is called esters. So let's look at the first one. So the first one, we said it's an alkane. So what is the structural what is the structure of the functional group of an alkane? So we say that an alkane, it only have single bonds between, and bear in mind that we say that when we're defining, we are only looking at the hydrogen and carbon atoms. So what does that mean? It means that the carbon is bonding to the hydrogen atoms alone. So what is the structural group? So for instance, maybe we have 2 C's which are bonding together. Then we now have OH. Bear in mind that a C, or the carbon atom, must both bond 4 times. Okay, so this will be the structure. I'm just making an example. Now, what is the name ending? It's called ANE. Okay, so if there were 5, it's gonna be pentane. So this name ending is so crucial. Then what is the condensed structural formula? This now it's CH3, CH3. Looking at this perspective here that we said, it's CH3 and CH3. Great. That was the first one. The second one, we have what we call alkenes. So what is the structure of alkenes? It will be like this. Then these ones, they have a double angle. Sorry, they have a double bond. So now you can actually see that they are no longer bonding the same way they were bonding. It's now having like this. So this would be like a small example for them. Then this is ending with an ENE. This is the name ending. Then it's gonna be CH2. Where is CH2 coming from? We are looking from this side, that on the condensed formula we are now looking on the structure which we have already written down. So it's gonna be C, which is bonding twice, and also this one which is bonding twice like this. Okay, so that's where we have it. Now everyone is happy, and now we know that this one here too is called ethane. Then this one is gonna be ethene. Okay, ENE. So you can actually see the name ending. So the name ending is so important, it's so crucial, it's so vital in the naming of this. All right, great. Now the third one, we have the alkynes. On the third one, we have the alkynes. So what do we know about the alkynes? Now the alkynes, they have a triple bond. Okay, so now you can actually see that 1, 2, 3, 4. Bear in mind that we say that carbon must always bond 4 times. So it has already bonded 4 times here. Then you can see that. So what will be the name ending? Alkynes. So it will be YNE. Okay. Then you can see now, looking at the structural formula, it's going to be CH, CH. Okay. Then if we're told to name this, you can actually see that this is an ethyl. Okay, to its eighth. Then now moving forwards, so these first 3, they are called hydrocarbons. Why are they called hydrocarbons? Because they contain only the hydrogen and carbon atoms. So that's why they are called hydrocarbons. Now, great. Now, moving forward from that part now, I want us to look at the fourth one. We said they are called the alkyl halides. Okay? It's called alkyl halides. So these ones now, they have something important about them, because now they are having C bonding with X, where this X now are the atoms which include F, Cl, and Br, as well as, let me just put, as well as I, which is iodine. So like we must understand that, okay, now C is bonding with X now, where X is, can either be fluorine, can either be chlorine, can either be the bromide, can either be iodine. So those are the so an important crucial part. And now they don't have a name ending because it depends on which one they are having right now. And now, for instance, maybe we can say we have a chloromethane. Okay, meth is 1. So if we're for instance having this, then we bond it with Cl, then we have our H here, we have our H. You can actually see this. Let me just write it down here on the structure. Okay, so we're now saying that Eg is bonding with chlorine. So you can actually see from this side that's, oh, okay, great. Now this is what we call, there's only one, so it's gonna be methane. Why is it methane? Because there's one carbon atom, and they are all single bonds around the carbon atoms. Then it's also included with the chloro, so it's gonna be chloromethane. Okay, so it's so important. So the structure, you can actually see that it's gonna be CH3 Cl. Then moving to 5, we have the alcohols. I'm gonna try to be fast as possible. We have alcohols. So on the alcohols, what is important is that you must understand that now they have this ending. So for instance, this is C. So this C must be bonded with OH. OH is illustrating or is representing alcohol. Okay, so for instance, maybe we can have okay, the end like this. Then we can have maybe ethanol. Okay, what is ethanol? Let me just write it down here. We can have ethanol. What is ethanol? Ethanol can be if we are writing this as a structure, it will be CC1 like this, then it has a OH. So to its eth, then ethanol, because the ending, the name ending, it's OL of alcohols. Great. Now, what is important also is the condensed structural formula. So the condensed structural formula in this sense is going to be CH3, CH3, and also it will have a OH. Okay, that will be the condensed structural formula. Now, number 6, we have the ketones. We're almost done, and we're going to look at the paper. So number 6, we have ketones. Number 6, we have ketones. Right. What are ketones? What is the structure of a ketone? So the structure of a ketone now is now different now. You can actually see that it's now a different scenario. Okay. So now you can see the functional group. It has a double here. It's bonded twice with oxygen. Now we're introducing oxygen. So what is the name ending of a ketone? It's ONE. All right. So for instance, maybe we can have propane. This one which we are having right now is prop. Okay. Propane 2,1. Why are we saying 2,1? Because we can see that the functional group is on carbon number 2 when we are looking on the parent chain. So that's why it's called propane hyphen 2 hyphen 1. The one who will say proper noun, it's gonna be wrong because you didn't illustrate where do we find the functional group. Then number 7, we said we have what we call the aldehydes. So now the aldehydes, now they are now amazing because now it's only like this. Then they will have their carbon atom. Then now they have their OH. Okay, now this is different from ketones. Ketones, they don't have OH, but aldehydes, they have OH, and they end as AL. And what is their name? They can be this one which I have, they are called ethanol. Great, because definitely we can actually see that you can say ethane 1 all. Why? Because you can actually see where there is the functional group, where we have the functional group of carbon atoms. Great. Now number 8, we have the ester, the carboxylic acids first. We have the carboxylic acids. So on the carboxylic acids now, it's now combining what is so important, or what I say it's so crucial. Sorry, this one doesn't have an alcohol, it's only an H. I did a mistake there. Great, then this one now is the one which have O, then it is OH. Like this. This is the carboxylic acid. Okay, so the name ending is going to be oic acid. Okay, so you're gonna see examples, so you're gonna see and get used to this as much as you are seeing the examples, because the examples, they are so important and so crucial. Okay, now number 9, we have the esters, which are the masters, which are so important. So the esters are so crucial because they have combination of alcohol as well as the carboxylic acids. All right, you can see this. We have O, we have C, H. You can see that. Then they are, their name ending is OET. Right, so their name ending is OET. So in this case, you can say that this is an ethanoate. Okay, so that's how we'll be able to name this. So this was just a background of this so important and so crucial things of this. So in order for you to use or to understand the IUPAC naming, of these carbon atoms, you must understand that always they begin by having a prefix. Then we have what we call the parent chain. Then we have the suffix. Okay, so this is what we have. So now, what is the parent chain? The parent is illustrating the number of atoms. Then prefix is where and what functional group, okay? Where and what functional group. Then the parent is the number of atoms, the number of carbon atoms. Let me just write it properly. Number of carbon atoms. Then what is the suffix? The suffix is the homologous series. So now we also understand, you must understand this small table which I'm going to create for you guys, that you must understand that the number of carbon atoms, let me just draw two. So the first one is for the number of carbon atoms. So if it's 1 to 10, 3, 4, 5, 1 it's meth, okay? This is the parent name. It will be meth. 2, it will be eth. 3, it will be prop. 4, it will be but. 5, it will be pent. 6, you know, 6 it's hex. 7 hept. 8 octane. 9 nano. 10 deca. So this is so important also and so crucial. Now without wasting much time, let's just look at the question paper which we have. I just wanted you to have this small background, but we are not really gonna focus on that small background. I want us to really look at the question paper, because the question paper is what has the crucial or the important thing which we want to look at today. So now on the question paper which we are looking at now, we can see on question number 2. Question number 2. So what are we seeing on question number 2? We are seeing that we are given the letters A to H in the table below, and they represent 8 organic compounds. Right, they represent 8 organic compounds. Now, the first one, we can actually see that, oh, okay, when we're looking at what we were doing right now with Fuyani, we were able to see that, okay, this is having CO, then we have OH there. Now we can actually look at this, what we have right now. We can actually see that the first one here, it's an ester because of the way its functional group. That's an ester. Well, what about B? We can see that it has a double angle. That's an alkene. We can also see CH3, CH2, CH2, CO, CH3. We can also like draw the structure so that you can know the names properly. This is an alkyne. C2H4 is an alkene, sorry. C2H6. So also what is also important, which is going to be able to assist you to be able to name this properly, is to know the general formula of these different groups. But nonetheless, now let's move forward. 2.1. Define the term unsaturated compound. What is an unsaturated compound? So an unsaturated compound, it is a compound. Let me do this. Right. So an unsaturated compound, it is a compound that contain carbon atoms. Sorry, it is a compound that contain double bond, contains a double bond or multiple bonds. Okay, that's an unsaturated compound which consists of those. Now 2.2. In 2.2, the question says, write down the letter that represents an unsaturated compound. Oh, this is great. Write down the letter. So we have already defined what's an unsaturated compound, and we say that, okay, an unsaturated compound is a compound that contains a double bond or a multiple bond. Now, since it contains a multiple or a double bond, what is so important, what is so crucial is to understand that, okay, it contains a multiple bond. So now let's look at what we have here on the structures which we were given above. So now looking at the structures which we have here, we can actually see that on B, we can see there is a double bond there. So definitely the first answer can be B. Then we can actually see C2H4 also on E is also a saturated compound. Okay, it's a saturated compound as well. Why am I saying that? Let's draw the structure of C2H4. It's going to be C and two H's, then also another H, another H. Definitely there's going to be a double angle. Okay, so a double bond. So that's also important, and that's also crucial. That's also important. That's also crucial. So the answers for 2.2 is gonna be B or A. Then 2.2.2. So this was 2.2.1. Now they say on 2.2.2, name the functional group of compound C. Name the functional group of compound C. How are we gonna name the functional group? That's so easy, because we can actually say that that's an aldehyde, all right, because of COCH, which we are having there. That functional group is gonna be on 2.2. So the answer is just easy. The answer will be, it will be in carbonyl. Okay, it will be a carbonyl. Then 2.2.3 to be a carbonyl. Then 2.2.3. Now the question of 2.2.3 is saying the letter that represents a chain isomer of compound C, right? A chain isomer of compound C. So what is important is to understand that what is an isomer as well. So now we are now looking, because an isomer is defined, then we have type of chain isomers. We have the chain isomers, we have position isomers. So now they are saying on 2.2.3, give the letter, or write down the letter that represent the chain isomer of compound C. Where is compound C? This is compound C. And we say that on, what do we know about compound C? It is in the functional group of an carbonyl. So which one now on these three on these 8 organic compounds are we given is going to be the chain isomer? So we can actually see that it's gonna be F, because it's a chain isomer, because we are talking about the carbonyl group. So it's ketones and aldehydes. When they combine now, they can actually see that they will respond and correspond with each other, giving us what we call the chain isomer, because they will have the same number of carbon atoms, they will have the same number of hydrogen, but the way they are positioned, the way they are written down is different. So the answer there is going to be F. All right, so the answer on that part is going to be F. Then on 2.2.4, now on 2.2.4 they say IUPAC name of compound G. Where is G? That's where G is. Great. So now we can see that. So let's count which one is the longest chain. So 1, 2, 3, 4, 5, 6. So the longest chain is 6, and we can see that they are all single bonds there. So we know that the single bond is a what do you call this? It's an alkane. So since there are 6, we say that earlier on when we're having this small table, that we say that we have the number of carbon atoms, the parent name. So since there are 6 here, we say it's hex. Okay, so what is it now? So we start by knowing the parent chains, that the parent chain is hexane, because we can see that they are all single bonds, and since they are single bonds, that means that this is a, since they are single bonds, what does this mean? It means that this is a alkane. So now moving forward from that, now let's look. Now we have a Cl and Cl here. Now we can see that on 1, 2 we have Cl, so it's gonna be 2, comma 1, 2, 3, 4. It's gonna be 2, 4. It's gonna be 2, 4. 2, 5. Sorry, dichloro. Have 2,5 dichloro. Let me just remove this, I'll edit later. Then we can also see that we have a chain there, an extended chain, which is CH3, which is on position number 3, methyl Hexane. So that will be the IUPAC name of that atom. Okay, great. Now moving forward now on 2.2.5. 2.2.5, they say that give the general form of the homologous series to which carbon E belongs to. Where is E? C2H4. That's easy because we have already seen that that's an alkene. So what will be its general formula? It's easy. So it's only going to be C N H2N. Let's prove that when it's C2, it's going to be C2 times 2 times 2, which is C2H4, which is the compound E. So this won't be that tricky and this won't be that hard as well at the same time. Now, okay, let's move on to 2.4. Okay, let's move on to 2.4. On 2.4, the question says, 2.3 first, sorry. 2.3. Define the term functional isomer. So earlier we said that we have the position isomers, we also have chain isomers, and we also have the functional isomers. So what are functional isomers? So these functional isomers, let me write it down. So these are compounds. So these are compounds. These are compounds with the same molecular formula but different functional groups. Okay, or you can say functional, or you can say homologous groups. What does this mean actually? So we are saying that, for instance, we will have maybe C3H8 and also C3H8, but the way these are structured, or these are written, or these are structurally drawn, they are different. They are from different homologous. For instance, maybe this one is going to be from an alkane, this one is going to be from the alkene, this one is going to be from this, but at the end of the day, having the same molecular formula and having different homologous series, or that will give us what we call a functional isomer. Now, great. Yeah, we are almost done. Please be patient. Now, looking at 2.4.1 now. Okay. 2.4.1. For compound A, write down the homologous series to which it belongs to. Where is compound A? So compound A, we can see that there is compound A. Then we can see the functional group. We have C, which is double bonded to oxygen, and also OH. So you still remember when I was doing the small overview? So this is so important to understand that that is belonging to the carboxylic acid. Okay, because of the double bond, and the C also bonding to an alcohol. All right, great. That will be in carboxylic acid. Now, the next question now is saying, next question is now saying, write down the structural formula of its functional isomer. Write down the structural formula of its functional isomer. So now we must write down its isomer. Okay, great. Now let's write it down. It's not that hard because now we already know that it's a carboxylic acid. So now we can draw its functional isomer. So it's gonna be easy. 2.4.2. So let's draw it together. H, which is now bonding to O, then bonding to C, H, and H. So you can actually see that these are two different things. Okay, so you can also see that these are two different things from this one. Okay, this one now we can see that this is an OH, which is for alcohol, and this one is for a ketone. Okay, it's for aldehyde, for aldehyde. Yes, so now you can actually see that this is now a different scenario, because now we are now having this. All right, so this is so important. Then you get your full 2 marks. So now doing 2.5, which is the last question of today, doing 2.5 point 1, compound D undergoes a dehydration reaction. Write down the. So what is dehydration? So we have what we call the concept of Zaitsev rule and Markov-Vinkov's rule. So those two rules are so crucial and are so important, because they contribute a lot when you are now looking at the reactions of these organic compounds and organic molecules. So those two are so important. So when now we are looking at the those two rules, the Zaitsev and also the Magnum Vehicle, we can actually see that we are looking on this dehydration process. We will be looking at what we call the Zaitsev and applying the Zaitsev rule. So now they're saying that they are going under the dehydration reaction. Now write down the IUPAC name of compound D. Let's look at where D is. Here it is. So write down the IUPAC name of compound D. So we are given C2H6O. So write down the IUPAC name of that compound. So we can actually see, I'll start by drawing so that maybe you can also see it as well. So there are two C's, then we have O, then we can actually see this is gonna be 1, 2, 3, 1, 2, then 3. You can actually see that this is the structural formula of the compound D. Right now we can actually see there are two carbon, so it's gonna be eth. Then due to this OH function groups, which means it's gonna be ethanol. So this is the ethanol. It's an alcohol. So actually it's an alcohol, which is called an ethanol. Now looking at the next question now, 2.5.2. 2.5.2, the letter that represents a product of this reaction. Okay, the letter that represents the product of this reaction, the letter that represents the product of this reaction is going to be product A. Okay, because during dehydration, we know that we will be breaking that alcohol, and it will give us water as well as the ethene. Okay, so this ethene or this alkene, let me just say as a functional or as the homologous series, let me just say an alkene. So when we are breaking this down, we already know that an alcohol, it will give us an alkene plus water. So what is the output, or what is the product which we're gonna get when the dehydration reaction is occurred? So it's gonna be an alkene. So in this instance, which alkene is it going to be? It's gonna be an alkene. So this alkene is going to be on E. All right, because we can actually see that we have C2H4, which is an alkene. Now looking at the next question now. Looking at the next question, the last question actually. So looking at the last question of today, name or write down the name or the formula of the inorganic reactant that is used in this reaction. Oh, definitely we already know that during dehydration they use what we call the sulfuric concentrated acid. Okay, they use the sulfuric acid, which is also known as H2SO4. But this is not correct if you don't write in bracket that this sulfuric acid must be concentrated, right? Concentrated, which means it's 100%. Okay, so those were the things which I wanted to highlight on this organic chemistry. On this first section, you can actually see it's 18 marks. So what is so important is to understand what I started by showing you guys, to understand the basic of organic chemistry, and also understand the different homologous series that we have in this concept of organic chemistry. So if you are able to know all your homologous series and know their functional group, and you can be able to write them down, you'll be able to also answer this question as the way I was doing. I believe that it was also be able to assist you and also have or give you a better understanding on how you approach these kind of questions. So till we meet again, have a good day and good evening ahead.